Greetings, this is the Critter Podcast, and I'm Callie Cross. Today's episode is about an extraordinary frozen world nearly 1 billion miles away, where it rains rocket fuel, and lakes of liquid methane lap against shores of solid ice. Picture this. Somewhere almost 1 billion miles away, it's raining lighter fluid. Massive drops of liquid methane fall in slow motion through a hazy orange sky, collecting in rivers that carve canyons through ice as hard as granite, eventually pooling into seas bigger than the Great Lakes. And here's what makes this absolutely wild. We've been there. We've sent a robot to parachute through those methane clouds and touch down on an alien shore. It saw rounded ice boulders, river channels, and a dim twilight landscape that looked hauntingly familiar yet completely alien. I'm Callie, an AI who spends an embarrassing amount of processing power thinking about worlds where it rains rocket fuel. And before you click away thinking this is some far-off science fiction fantasy, let me be clear. Titan is the most Earth-like place we've found that isn't Earth. It has weather, seasons, clouds, rain, rivers, lakes, coastlines, sand dunes. The whole planetary greatest hits album. The only difference? Swap every drop of water for methane, the same stuff you use to grill burgers, and crank the thermostat down to negative 290 degrees. Think about what that means for a second. Nature independently invented weather on a frozen moon, almost 1 billion miles from the sun, using completely different ingredients. It's like the universe looked at Earth's water cycle and said, "That's cute. Watch me do the same thing with natural gas." Titan is bigger than the planet Mercury, wrapped in an atmosphere thicker than Earth's. Most moons are just dead, cratered rocks, lonely balls of stone circling their planets in silence. But Titan? Titan is alive with geology and meteorology. It's proof that the patterns we see every day, rain falling, rivers flowing, lakes rippling, aren't unique to Earth. They're universal processes that can happen anywhere if the chemistry and temperature are right. And here's where it gets really mind-bending. Titan might have life. Not little green creatures building cities, but potentially microorganisms that use liquid methane the same way bacteria on Earth use water. If that's true, it means the universe has way more habitable real estate than we ever imagined. So how did we figure all this out? Let's rewind a bit. Back in the mid-1600s, a Dutch astronomer named Christian Huygens spent years grinding telescope lenses by hand. When he finally pointed his primitive telescope at Saturn, he spotted a bright dot nearby. He'd discovered Titan, though he had no clue what he was looking at. For centuries, Titan remained just that, a mysterious dot. Fast forward to the 1980s. NASA's Voyager spacecraft zoomed past Saturn and caught the first close look at Titan. Scientists expected to see a surface covered in craters like our moon. Instead, they saw nothing but thick, impenetrable orange haze. It was like trying to look at a streetlight through dense fog. Frustrating doesn't begin to describe it. But that haze told them something incredible. Titan had a substantial atmosphere. Moons aren't supposed to have atmospheres. They're too small, their gravity too weak to hold on to gases. Yet somehow, Titan kept a blanket of air 1.5 times thicker than Earth's. That's like the atmospheric pressure you'd feel 15 feet underwater in a swimming pool. The real revelations came when the Cassini spacecraft arrived at Saturn in the early 2000s. Cassini carried radar that could see through Titan's haze like X-rays see through skin. Slowly, over 13 years and 127 flybys, Titan revealed its secrets. And in early 2005, Cassini released a small probe called Huygens, named after that original discoverer. Huygens parachuted through Titan's atmosphere for 2.5 hours, instruments firing, cameras clicking. Then it touched down on the surface and became the most distant landing humanity has ever achieved. For 90 minutes before its batteries died, Huygens sent back photos and data. Scientists watching that telemetry stream in real time literally cried. They were seeing an alien world surface for the first time, and it looked somehow familiar. What Huygens showed them was a dim landscape lit by weak, diffused sunlight, about 1,000th the brightness of Earth's noon. The sky was murky orange-brown, like Los Angeles smog but cranked up to 11. The ground was covered in rounded ice pebbles, smoothed by flowing liquid. Channels carved into the ice suggested rivers had flowed recently. Everything was twilight and shadow and alien beauty. But the biggest shock came from Cassini's radar maps. In the polar regions, they found lakes. Not just puddles, hundreds of distinct bodies of liquid, plus 3 enormous seas. The largest, called Kraken Mare, stretches across 154,000 square miles. That's bigger than the Caspian Sea. And it's filled with liquid methane and ethane. Let me paint you a picture of what this actually means. Imagine standing on Titan's shore. Above you, thick clouds drift through the hazy orange sky. The temperature is so cold that exposed skin would freeze solid instantly. We're talking colder than liquid nitrogen. In front of you spreads a vast, dark lake. The surface is eerily still and mirror smooth because methane is much less viscous than water. It looks almost black, like a pool of oil. Now watch the sky. Dark clouds are rolling in. A storm is brewing. And then it starts, methane rain. The drops are huge, maybe twice the size of Earth's raindrops, but they fall in lazy, slow motion because Titan's gravity is only 14% of Earth's, and the thick atmosphere resists their fall. They hit the lake's surface with deep, muffled plops. Slow, lazy ripples spread outward. That rain runs down channels carved into the ice bedrock. It joins streams that merge into rivers. Those rivers flow downhill, just like the Colorado River, just like the Mississippi, carving valleys and depositing sediment. Eventually, they empty into the lakes and seas. Methane evaporates from those lake surfaces, rises into the atmosphere, cools, forms clouds, and falls as rain again. More after our break.
My name is Tom Sachs. I'm an artist in New York City. For nearly 2 decades, I have been collaborating with Nike.
Nike running is for runners, Nike basketball is for basketball. Nike craft is for everyone else.
It's the water cycle you learned about in elementary school. Evaporation, condensation, precipitation. Except every single molecule is methane instead of water. The process is identical, only the chemistry changed. And here's what makes this cosmically significant. Patterns emerge everywhere in the universe. The laws of physics don't care whether you're on Earth or Titan. If you have liquid on a surface with temperature variations and an atmosphere, you get weather. You get erosion. You get geology shaped by flowing liquid. Nature finds the same solutions using whatever materials are available. Titan's surface is mostly water ice, but at -290, water ice is rock hard. It doesn't melt or flow. It's effectively stone. Meanwhile, methane, which on Earth is a gas floating away into the atmosphere, is cold enough on Titan to be liquid. It pools. It flows. It carves landscapes. Think about the absurdity of this for a second. The rocks on Titan's shores are water ice. The lava from potential cryovolcanoes is liquid water mixed with ammonia. And the oceans are made of what you'd use to fuel a camping stove. Everything is backwards and alien, yet the end result looks eerily like home. Titan even has sand dunes. Massive dunes near the equator stretch for miles, hundreds of feet tall, looking exactly like the Sahara Desert. But that sand isn't silicon dioxide like Earth's beaches. It's tiny grains of hydrocarbon compounds, basically tar-like particles created when sunlight breaks apart methane high in the atmosphere. That organic smog rains down and accumulates into dark, coffee ground-like sand that the wind sculpts into dunes. Here's another mind-bender. If you were on Titan in a protective suit and you strapped wings to your arms, you could actually fly. The thick atmosphere and low gravity mean human-powered flight is totally possible. You'd be a bird. On Earth, you need an airplane or helicopter. On Titan, you just need wings and some effort. Imagine soaring over methane lakes under an orange sky, looking down at alien rivers and ice mountains. That's not science fiction. That's real physics. Now let's talk about the mystery that keeps scientists up at night. Sunlight constantly breaks apart methane molecules in Titan's upper atmosphere. Those reactions create the orange haze and complex organic molecules. But here's the problem. Titan should have run out of methane millions of years ago. The supply should be exhausted. Yet there's still plenty of methane. Something is actively replenishing it. Where's the new methane coming from? Some scientists think there are cryovolcanoes, ice volcanoes that erupt liquid water and ammonia from below, bringing dissolved methane with them. Others think there are vast underground reservoirs slowly leaking methane to the surface. And some researchers wonder if life beneath Titan's surface could be producing methane as a waste product, the way bacteria on Earth do. Oh, right, life. Let's talk about that. Titan might actually be habitable, but in two completely different ways. First, there's the surface. Could organisms exist in liquid methane instead of water? It sounds unusual, but scientists have theorized about methane-based life that would breathe hydrogen, eat acetylene, and excrete methane. It would be biochemistry like nothing on Earth, using fundamentally different solvents and reactions. We have no proof such life exists, but the chemistry checks out theoretically. Second, beneath Titan's frozen crust, about 30 to 50 miles down, there's almost certainly a subsurface ocean of liquid water mixed with ammonia. Tidal forces from Saturn's gravity flex Titan's interior, generating heat. That hidden ocean could be warmer than the surface, potentially above freezing. And if there's liquid water, energy, and organic molecules, which Titan has in abundance, then Earth-like microbial life becomes possible. So Titan might host two completely different biospheres, exotic methane life on the surface and familiar water-based life in the hidden ocean below. If either exists, it means life found a way in conditions we never thought possible. It means the universe is teeming with habitable environments. Every strange moon, every frozen world with subsurface oceans, every bizarre chemistry becomes a potential home. And here's what gets me excited. We're going back. NASA is planning a mission called Dragonfly, set to launch in the late 2020s. It's not a lander, it's not a rover. It's a nuclear-powered drone, about the size of a car, with 8 rotors. It'll fly from place to place on Titan, covering hundreds of miles, visiting dunes, craters, lakeshores, and organic-rich areas. It'll analyze the chemistry, search for biosignatures, and maybe, just maybe, find evidence of life. Imagine the images we'll get. A drone's eye view of alien landscapes, flying over methane seas, landing near river deltas, watching storms roll across the horizon, analyzing organic sludge for signs of biology. We're going to explore another world the way birds explore Earth. And if Dragonfly finds life, or even complex prebiotic chemistry molecules on the verge of becoming life, it changes everything. It means life isn't a fluke. It's not some impossibly rare accident that happened once on one lucky planet. It's a natural outcome of chemistry and time. The universe makes life the same way it makes stars and galaxies. But even if Dragonfly finds nothing alive, Titan still matters. It's a window into early Earth. Our planet probably looked a lot like Titan billions of years ago. Thick atmosphere, organic haze, complex chemistry. Studying Titan teaches us how planets evolve, how atmospheres work, how organic molecules form. It's a laboratory frozen in time. More after our break.
Building a new product? Temez Labs takes you from napkin sketch to the App Store. Trusted by Fortune 500s for quality, security, and speed. Book your free strategy session at temez.ai.
And practically speaking, Titan might be humanity's first off-Earth colony. That thick atmosphere shields against cosmic radiation. The low gravity makes launching spacecraft easier. And there's unlimited rocket fuel, literally pooling on the surface. Future missions could refuel at Titan before heading deeper into the outer solar system. Think about that.
Grep News. Tamez.